Welcome to Fish University, your one-stop shop for the science behind fish management. It is part of the Natural Resources University Podcast Network. I'm Wes Neal, your host. I'm an extension professor of fisheries and a researcher for Mississippi State University. Join me as I talk to researchers, managers, and landowners about the tools and science and the tricks of the trade for managing fish, water, and habitat. The goal is for you to have better fishing and a healthier aquatic ecosystem. So grab a notebook and the beverage of your choice and relax and enjoy Fish University. Welcome to Fish University. Have you ever wondered how newly formed volcanic islands become colonized with freshwater fish species? When these land masses emerge from the salty deep and the lava solidifies, eventually rainfall will form rivers, lakes, and lagoons. So how do freshwater fish come to be found in these systems? Do they come in on the feet of birds? Are they marine species that get trapped in and are eventually adapt to the low salinity water? To help me dig into these questions, my guest today is tropical river expert Dr. Gus Engman from the University of Tennessee. Gus, how are you doing today?
I'm doing great, Wes. I'm really excited to be on this podcast, and thanks for inviting me on here.
Is it as hot in Tennessee today as it is here?
It's incredibly muggy today. Like, we had a rain, and it just turned, 100% humidity this morning. It was crazy.
Yeah, we had a massive hailstorm about 2 months ago that did a bunch of damage to my house and vehicles. And today the reconstruction began. These poor guys are out in front of my house ripping siding and gutters off, and it's going to be 95 to 97 degrees the next couple of days.
Man, so, I don't think it's that hot. It's like in the lower 90s, but it's definitely like real feel over 100 or something like that. So, gosh.
Well, I'm glad we're inside. So, well, thanks for joining us today. One of the things I like to have my guests do is tell a little bit about their background, how they got into biology in the first place and ended up where they're at today.
Yeah, so I guess like a lot of people in this field, I got into just biology and sort of aquatic or marine biology because of like a very young sort of just fascination with fish. I grew up, fishing, just looking at fish in a duck pond, things like that. There was just this like sort of fixation on the underwater world and fish. And so eventually, I kind of always just wanted to be a marine biologist is what I would always say as a kid. And did end up going to the University of Miami to study marine science and biology. So that's kind of where, I got my first sort of taste of actual research and, really formal training in this world. So I have a kind of convoluted story to go from marine biology to sort of freshwater, but as we'll see in this podcast, I assume there's a lot of connection there. So again, studied marine science and biology at the University of Miami. And then another part of my background is that I grew up in Puerto Rico a little bit. I moved there in high school. And so, learned to dive there. And I was always kind of focused on the marine environment, but then ended up moving back after my undergraduate degree and started doing research in freshwaters in the rivers with my master's advisor, Alonzo Ramirez. And that's where I kind of got into this world of studying migratory fishes, and then there's this big connection because we'll talk about their life histories.
So you lived in Puerto Rico for a while. Now you do research down there. Is there any other places that you do research? Other international locations?
International. So I just started a collaboration with some folks in Honduras, and that actually came out of the research that I had done in Puerto Rico. I think, you were at that. I believe at that first Latin American and Caribbean Fisheries Congress, right? And so I was there, gave one of my talks on amphibious fishes, and a researcher named Wilfredo he's from Honduras, but he's at a university in Chiapas in Mexico. He just kind of came up to me and mentioned, we should do some research on the gobies in Honduras, because I know I'm catching those Cystidium gobies, and we don't know if they're the same species that are occurring all the way across the Caribbean and Puerto Rico, or they're different. And so that sat on the back burner for a few years, but then luckily I got into it's called the Smith Global Leaders Fellowship here at University of Tennessee. And so they give you a little bit of money to start an international collaboration. So just this year, I went to Honduras with Wilfredo, and we collected some Cystidium gobies, and there's also some researchers there at the National University of Honduras, where we're kind of starting to work together to hopefully do some research on, again, to see if there's the same species that are occurring in Puerto Rico occur all the way across the Caribbean, and also just kind of help them do general research on their fishes in the rivers there, because it's kind of a wide open world down there. Hasn't been a ton of research on fish and rivers in Honduras.
So let's talk a little bit. Let's step away from fish for a second. Let's talk a little bit about geology. These Caribbean islands that you've worked in, and as well as the mainland, but the Caribbean islands are volcanic islands. So a hot spot within the floor of the ocean, volcanoes build up over time, make islands, chains of islands, but they're relatively young, right? I mean, we're talking millions of years, not necessarily hundreds of millions of years or billions of years like some of the continents are. So when these things are created, at first they're relatively not inhabitable. I mean, they're going to be giant lava rocks that are hot and they cool down. And then eventually, through natural processes, rainfall, weather patterns, rivers begin to form, vegetation begins to colonize. And at some point in time, we end up with freshwater resources on these islands that are isolated by usually hundreds of miles of marine environment. And every one of these islands that has enough of a watershed or enough of a river system or whatever has freshwater fish species.
Yeah.
Where do they come from?
That's a great question. Great question. And one really important sort of source of freshwater fish to these islands are these fishes with these migratory life histories. So primarily amphidromous species in the tropics. So in amphidromy, fish live as adults in freshwater streams, and then they send their larvae out to the marine environment, where they have a pelagic larval phase of some duration. And for some of them, they can be pretty long. Some species around the world might be out there for 6 months or longer. And then they return to fresh water. At the end of that larval phase, there's a strong instinct for them to find fresh water and swim up against currents. So we think that that's, again, the source of a lot of the fish that occur on these tropical islands. And so if you go to, again, these oceanic islands, ones that are pretty separated from main land masses, you'll find that nearly all of the native fish in those freshwaters are amphidromous, or maybe another form of diadromy called catadromy. And so there's a lot of these tropical islands that don't have any native fish that have a completely freshwater life history, where they spend all of their lives in freshwater as their typical life history. And so there's this idea that they colonized from the ocean. And so, for example, the majority of amphidromous species come from the family Gobiidae, and that's the gobies. That's also one of the most speciose families of fish in the world. The majority of them, Gobiidae, are marine species. So the idea is that, evolutionarily, the branches of Gobiidae that became amphidromous were originally fish that had a completely marine life history.
Okay, so let's dissect that a little bit. So if you're a goby, an amphidromous goby living in Honduras, for example, you live happily in the stream, you come down the stream, you spawn probably in the stream or near the estuary, the eggs are washed out to sea, or they hatch and the larvae are washed out to sea. They're going to spend some time at sea, and depending on what ocean currents are in that area, they could be picked up and taken somewhere else, and eventually, over time, the odds of one of these larvae washing into a newly formed island are relatively high. And then if the conditions are right, if habitat's right, they can come in, metamorphose, swim up the stream, and become new inhabitants of the island. That's what you're saying, right?
Yep, that's right.
So with catadromy, you mentioned catadromy. If people may be familiar with catadromy with the American eel, which is kind of a neat thing. It's the opposite of salmon. Everybody knows what salmon are like. Salmon live as adults out in the ocean. They swim up into the rivers to spawn. If they're a Pacific salmon, they die. If they're Atlantic salmon, they can spawn again. But then their larvae hatch out in the stream. They become smolts. They come down the stream. Eventually, they go back out into the ocean and complete their life cycle. Eels do the opposite. And the eels actually, I should do a whole show on eels because eels are probably one of the cooler freshwater fish that we have. Eels live in the rivers. They go out, an eel could be living in the Mississippi River up near Minnesota and then migrate all the way down the Mississippi River, all the way through the Gulf of Mexico, all the way around Florida and out into the Sargasso Sea where they spawn. And then we won't even get into the crazy life history of what happens to them after they spawn and all the different forms that they take. But eventually they get washed into a river somewhere else and they colonize that river. In a lot of these islands, eels tend to be found because of that life cycle. Gobies tend to be found and a handful of other species. Usually they're not real rich systems, right? They're usually a handful of species.
No, yeah, typically, these oceanic islands are typically low species richness. So, for example, Puerto Rico, one of the bigger of the Caribbean islands, is one of the greater Antilles, has about 9 native species. If you count the American eel, and then there's a handful of gobies, closely related species called sleepers, and the mountain mullet.
Yeah, the mountain mullet is a cool fish, in my opinion. I think it's a really neat fish because it is a mullet like the marine mullet people are familiar with, but they almost have a life history of like a small trout.
Yeah. Yeah, they're kind of behavior like a small trout, swim in the water column. If you're into fishing, you can catch them on a fly, and that's a really cool thing to do. So,
you ever caught one on the fly?
Let me see. I've never caught one on a fly. I haven't. It's weird. I said I moved to Puerto Rico when I was in high school, and so I lived in upstate New York before that, and I was fly fishing there, and then again, you think of the marine environment when you think of Puerto Rico, and so I actually left my fly fishing gear with my uncle, and I didn't do it down there, but I have caught them. I mean, a fly would be I've caught them on really small, kind of like jig things that look a lot like a fly,
I've only targeted them like once or twice, and I don't think I ever landed one.
They can be like, you'll see them if you throw something bigger, kind of rooster tail looking thing, you'll see them chasing it sort of, but they can be kind of shy. And so I know that people catch them on flies. So like a smaller fly I think is a pretty good way to go.
Well, let's talk about the gobies for a little bit because they're a really neat fish. What makes a goby a goby?
Okay. So one strongly identifying feature for a goby is going to be fused pelvic fins. So most fishes that you find, they're going to have paired pelvic fins, so 2 separate fins, but the gobies have their pelvic fins kind of fused into a single fin, and they use that in a variety of ways. They're typically benthic, or they're benthic fish, so they're going to be on the bottom and they kind of rest on that pelvic fin sometimes. But in these amphibious gobies, something that's really interesting that they use that pelvic fin for is actually climbing waterfalls. And so you see it in Puerto Rico, Hawaii, a lot of places where there are these Cycidium gobies, and they can actually suck on to like the vertical or even past vertical surfaces with that fin like a sucker, and then they use the fin and their mouth to kind of inch their way up waterfalls. So very interesting, very cool behavior, and again, it's part of that sort of life history of colonizing these new habitats.
Are they the only group of species that can climb waterfalls like that?
That's a good question. I mean, climbing just like that, to be honest, I'm not sure. I know there's like clingfishes that are Gobiaceae, I believe is that have kind of a similar adaptation, but I don't know about climbing waterfalls in that same exact manner. I've only heard about it in Cycidium gobies.
It just seems like it would give them the advantage of colonizing habitats with no other fish species.
Yeah. And so, if Wes, you mentioned that there's relatively few species, but there still is this sort of assemblage in these low species tropical island rivers. And so the gobies are often the smaller and more likely to be algivorous, so feeding low in the food chain fishes. And then there's predatory fishes like sleepers and maybe the mullets. And so one kind of theory about this waterfall climbing ability is that those gobies are further colonizing habitats that there are not predatory fishes in. So they evolve this ability to climb these waterfalls so that they can access these predator-free habitats that are upstream of the first waterfall in the stream. And so again, so a lot of these larger predatory migratory fishes live kind of in the downstream portions. They don't have the ability to climb the waterfalls, and the gobies kind of, they occur all over the stream, it seems like, in Puerto Rico at least, but potentially the ability to get above waterfalls can be advantageous to them. And so that's the theory about why that extreme climbing ability evolved.
You mentioned the sleepers. They're closely related to the gobies. They look very similar. They do not have the fused pelvic fins. But a big mouth sleeper, which is a common one in the Caribbean, it looks like what its name implies, a huge mouth. It just lays on the bottom looking up, waiting for something to come by. And it can eat, I would imagine it could probably eat something half its size. So a little Cystidium goby probably wouldn't stand a chance to something like that.
No, absolutely not. It would definitely eat. They do eat Cystidium gobies, and there's another goby in the genus Awaus that they would absolutely eat. And so, yeah, that's a great point. Yeah, the sleepers are very closely related family to the gobies. So sleepers are a family of the Otridae, gobies are Gobiidae, and then they're in like a super family together.
Yeah, and we've kind of talked about the major players here with the sleepers, the gobies, the mountain mullet, the American eel. Let's talk a little bit about the life history, because we mentioned amphidromy, but once these fish are spawned and they go out, they tend to come back, and that's a really neat process of these returning. There's a whole fishery around it. Let's talk about that a little bit.
Yeah, that's a great thing. It's something I studied for my PhD research. So yeah, again, all of these fish have this larval stage in the ocean, and there's a time at which they're going to return to fresh water. As far as we know, we don't know about any sort of like natal homing that necessarily occurs. It's still kind of an open question, but it's, in salmon, there's kind of this paradigm that they always come back to the river that they were born in. I'm sure there's definitely some variation there, but people kind of think of it that way. As far as we know, that's not necessarily what occurs with gobies. But especially for all of these fish that we're talking about have this life history with larvae in the ocean. But for some of the gobies, especially the Cystidium gobies, there's some really strong temporal cycles in their migration from the ocean into freshwater. And so one cycle that kind of occurs around the year is related to, we think, to rainfall, to the amount of rainfall that occurs in the year. So you generally have overall these, there's the period of time where there's the most fish that are making these migrations from the ocean to freshwater is during the rainier time of year. So that's like from May, June into December, January in Puerto Rico. And then there's another cycle within that, especially for Cystidium gobies, but it's also true for Awaus, that within that annual cycle, there's monthly pulses of recruitment. There's actually a fishery targeting those post larvae as they migrate from the ocean to the fresh water. And you think, then they're doing this when they're about 25 millimeters in length, so like around an inch or so in length. So you would think, like, how could there be a fishery? Why would people ever try to catch them? Well, what happens is they have mass migrations that are linked to the lunar cycle. So for the Cystidium gobies, nearly all of their migrations occur during the last quarter moon phase. So when you got like that half moon, but you're moving towards a new moon, it rises kind of at midnight, and you look up and you see that half moon. And just in those first 2 to 3 nights of that lunar phase, there's these mass migrations of Cystidium gobies that occur. And in Puerto Rico, they call the larval or the post-larval stage of Cystidium gobies, they call them seti. So in cities in like the northwest area of Puerto Rico, or the mouths of rivers of the northwest area of Puerto Rico, people will fish for them during that last quarter moon phase. And you'll see that they fish with them with mosquito nets. So like the kind of mosquito net you would hang over your bed, they pull them like a seine right there at the river mouth. And I mean, I've seen times where the river is completely full of these post larvae. It's really interesting. They're clear when they're coming back. Right when they make that transition from ocean to freshwater, they're completely clear. So if there's a big migration that's happening, and you look down in that river at night and like shine a light, it looks red, and that's because again their bodies are clear, but you can actually see their heart and gills red from all the concentration of blood. And so like the bottom almost looks red from that when there's a ton of them. So there's a lot of them coming through, and so people catch them and then you eat them whole.
So they're catching these, filling up 5-gallon buckets full of what, tens of thousands or hundreds of thousands of larvae for a 5-gallon bucket. How do they eat them?
There's a lot of ways that people eat them, but the most common that you hear of in Puerto Rico is called the empanada de seti. So again, seti is the name for post-larval Cystidium gobies in Puerto Rico. And the empanada it's not like a typical empanada or like what they call an empanadilla in Puerto Rico. It's more like a tamal, or what they call like a pastel in Puerto Rico, where it's like made, the sort of dough or the masa is made with like, I think they use like mashed plantain and yuca, and they cook up all the little fish, and then they're kind of folded in the middle, and then they fold that all up in a plantain or banana leaf. And then a lot of places do it on a grill. It's really good when it's grilled, and you get a little bit of smoky flavor from it. But there's a lot of ways people eat them. There's restaurants that serve it on top of pizza. There's something called salmorejo that they make with it, where it's just kind of like a little stew with all these fish in it. But yeah, the most common, you might, if you go to the city of Arecibo, you might, especially during that recruitment season, you might see like food truck type things selling empanadas de seti.
I wonder how it would be in ceviche.
I think it'd be good. I've heard of a sushi chef that does them. I think they'd be good because it's a very mild flavor. Like it's kind of, I mean, I've had them alive before out with the fishermen, and like they just taste like maybe like a mild shrimp flavor, you know?
Now, so I know that the eel goes through a transition when it comes in, it comes in as, well, floats around as the leptocephalus for a while, then it comes in as, what is it, an elver, and then it will transition into a yellow eel before it comes up the stream. Do these other species, do they transition or metamorphose in any way?
Yeah, definitely. They similar sort of transition and metamorphosis. Yeah, those elvers are clear, just like the post-larval gobies and sleepers. And so, yeah, they come in clear, and especially those Cystidium gobies, because they kind of like this pulse migration. It happens really quick, and it seems like they make their way upstream very quickly. So they'll come in, and like if you're out there on that first night of that last quarter moon phase run, they're coming in, people are catching them clear. But then if you go just a little upstream, maybe you go the next day or 2 days after and start catching them just a little upstream of that, they've already got full pigmentation. Their mouth has moved. It's kind of more terminal when they're in their post-larval stage, and is, within a day or two, you see it migrating downward to be more ventral facing. And they get these bars and coloration, and they acquire their pigment within a day or two, and they're just kind of making that migration upstream. So, and it's the same thing with the Awau goby, with the sleepers. Again, they're clear, and then they kind of go through this metamorphosis. But I think that it seems like in the Cystidium gobies that metamorphosis happens the fastest.
So now these fish have metamorphosed. They're starting their way up the river. Historically, they go up until they reach some kind of a barrier, usually a waterfall. If they're a Sycydium goby, they can climb the waterfall. If they're not, that's pretty much the end of their journey upstream. At one point in time, humans colonized a lot of these islands, and one of the things we like to do as humans is to impound water, to build reservoirs, build lakes. So a lot of these islands have lakes or reservoirs built on them that usually involve some kind of dam. And unless it's a little lowhead dam or something of that nature, a lot of them are pretty much impassable barriers, right?
Yeah, especially you have a large dam, like a lot of the ones we built in Puerto Rico. They tend to be these impassable barriers, and then so there's a complete loss of the native fishes in these reservoirs.
Yeah, so you've done a lot of work in Puerto Rico with the stream fishes. Most of my career was built doing work in those reservoirs, and when you build a barrier that a fish can't pass, you're not going to end up with any native fishes in the reservoirs. Most of these reservoirs are completely devoid of fish at all, and the only solution if you want to have fisheries in those systems is to stock fish from outside. So a lot of the reservoirs in Puerto Rico and elsewhere, the fisheries are comprised of non-native fish, introduced fish that come from North America, South America, Africa, and so forth. So it's usually a lot of times it's a really unique combination of species that end up in the reservoirs, but none of them are actually native to the island themselves. And none of them have really evolved together. And like in Puerto Rico, for example, we have largemouth bass, bluegill, and channel catfish from the U.S. But we also have some of the New World cichlids like peacock bass, some invasives that have shown up, some other cichlids. We've got tilapia from Africa. And now all of these species have to sort of figure out how to behave together. It's a real interesting situation. And it's fine as long as they're behind that dam and they're in this completely artificial situation. But the problem is like every reservoir, these fish can escape. They can go downstream and cause problems. So with all your river sampling that you've done, have you encountered a lot of these exotic species downstream?
Yeah, so that's a very interesting question. So I started out my career in river sampling in Puerto Rico in the Rio Piedras, which is the most urbanized river in all of Puerto Rico. So there were many non-native species in that river when I started doing research on it back in 2009. But in terms of abundances, they weren't, the kind of native fishes tended to dominate. And so you mentioned this kind of intentional stocking, Wes, and I think a really interesting pattern that we saw in Puerto Rico is it seems like most, or maybe even arguably all of the fish that were intentionally stocked, like those largemouth bass, the peacock bass, even the tilapia, never became like widely invasive in the rivers. And again, this is something I think has been shifting since through our careers, especially through mine, that when I first started out, it seemed like even throughout the whole entire island, there may be some of these introduced species, some of those ones that were intentionally introduced, but a lot of the ones that tended to occur in the rivers are the ones that were unintentionally introduced, things like the armored catfishes. Now we're starting to see another New World cichlid, the Amphilophus genus, that are really kind of blowing up in terms of their abundances. And so we've started to see kind of expansion of especially the unintentionally introduced fishes, and now in some places it seems like they're getting pretty abundant relative to the native fishes. So it's a really interesting thing that somehow, back in, they started doing that. A lot of that stocking happened in the 30s, right? Or even before. And then some, like I think it was the peacock bass probably came in like the 70s, right? But, a lot of that, they've been there for a long time and they were in the reservoirs for a long time, and it wasn't like they were just taking over the rivers. But it just seems like we keep finding more and more introduced fishes. The Clarius, the African walking catfish, made a lot of news as a recent introduction. And some of these ones that are getting put in that are coming out of the aquarium trade or wherever else are doing a better job of sticking in the rivers, it seems like, and spreading around. And so it's a big concern. I think more recently for the kind of non-native fishes.
Some of the earliest introductions by biologists, I would argue we probably didn't have due diligence at that point in time on what their potential impacts would be. But nowadays, if a fish is introduced, and they're just not really introduced a whole lot intentionally anymore, there's a whole process of making sure that that species isn't going to cause problems both within the receiving environment and if it gets out of that.
Yeah.
But the problem is that you know both accidental introductions occur and intentional introductions that are maybe not malicious. It might be something as simple as, hey, my pet pacu has gotten too big for the aquarium and I've gotten so attached to him I don't want to kill him, so I'm just going to let him go in the local lake. As much as you love your fish, that's not a good idea because of the potential consequences, because it only takes two pacu, a boy and a girl, and then we've got a whole new problem. But yeah, I remember when I was part of a process where we were looking at the potential to introduce a new species to Puerto Rico reservoirs. We never did, but it was one of the larger peacock bass species. And one of the things I recalled from that, all the footwork that went into trying to determine whether or not it was a good idea or not, was that in all of the river sampling that you and Tom Kwok and Patrick Cooney did, I don't believe you ever caught a butterfly peacock bass in a river, even though you sampled below dams.
Yeah.
And so that was pretty good indication that the rivers weren't suitable habitat, at least for the butterfly peacock bass. And the species we were considering was even more of a large system species. We never did introduce the fish, but we did all the legwork to determine whether or not it would be a good idea. But yes, you're right. Things like the Amphilophus species, the jaguar guapote, these fish are introduced through either people letting them go from aquaria or escaping from outdoor ponds or something. They're causing problems, and they're causing problems in the reservoirs as well. In fact, I've got a paper that's coming out pretty soon that we looked at the effect of Amphilophus and the jaguar guapotes, and we're finding complete recruitment failure largemouth bass in reservoirs that they exist in. And in fact, they've largely extirpated bass and bluegill from several reservoirs. So, I mean, now those are also non-native fish, but they are important sport fish.
Man, that's wild. Yeah, those Amphilophus. I mean, you mentioned the jaguar guapote, but the Amphilophus, they get super abundant, and you could see them. You go to like any reservoir now, and you look in there, and it's just like something. I mean, you and I both remember a time when it wasn't at all like that, not that long ago. Yeah.
Oh yeah, I started my career down there in, I guess, the late 90s, and those species did not occur on the island at that time. Hello, everyone. Thanks for listening to Fish University. Do you have a question or a topic for the podcast? If so, you can email me at Wes, that's WES, .Neal, that's NEAL, at Mississippi State, that's MSSTATE.edu. Or instead, please visit the Fish University Facebook page. On the Facebook page, you will find useful articles, videos, stories, and other information, as well as updates on upcoming podcasts. Not to mention, you can send me a private message with questions or suggestions. Just search Fish University and look for our colorful logo. And please follow the Fish University page. We need your support. Now back to the show. Let's talk about something a little happier, and that is one native species, the bigmouth sleeper. Despite the fact that it is an amphibious species, it needs to go out to the ocean to spawn. Somehow, and we still don't understand this at all, it has a self-sustaining population in one of the highest mountain reservoirs on the island, in Curite Reservoir. And we don't have a clue why, what makes that reservoir different. It's got largemouth bass, it's got peacock bass, but it's the dominant predator species in that lake. And there's all size classes, so everything from a 30 millimeter fish up to a 300 millimeter fish. These are big fish. I mean, these are a healthy population of all sizes. You have any thoughts on why they might be able to survive, or not survive, but to thrive in that reservoir and reproduce?
Yeah, it's a really interesting question, and I just have kind of my ideas, not anything that's been tested, but So one thing about big mouth sleepers in general, as an amphibious fish, is that they do seem to have, even in their kind of like in native environments, a little bit more flexibility in that life history. So if you go to, for example, Lake Nicaragua in Nicaragua, you'll find big mouth sleeper there, and it seems like they're reproducing entirely within that lake. Now that there is access to the ocean down through the San Juan River, but it's so far from the ocean that I think the general thinking is that those sleepers that ended up in that lake and other similar lakes reproduce entirely within fresh water. So there could be, I mean, and I think that something that, when you study these amphibious species enough, you find examples of fish that maybe the larvae didn't make it all the way to the ocean. So there's always this kind of gradient, in biology, everything's always a gray area, right? But especially it seems like the sleeper of the fish that we have in Puerto Rico is the one where there's kind of these examples of it maybe reproducing naturally in freshwater before. And then the other thing about the thing about Carite, isn't it the furthest upstream dam on the single longest river in Puerto Rico? So one idea that's other people have talked about too is that maybe that population, because it was so far upstream already what had this natural propensity for not being fully amphibious, right? Maybe those, when you start thinking about when you get far enough from a river, that trade-off of sending your larvae out to the ocean, or far enough upriver, that trade-off of sending your larvae out to the ocean is a bad one, right? Because there's more time that they have to migrate, more potential for mortality, and so you start kind of transitioning back to or to a fully freshwater life history. So it could just be that just by chance that population already had this kind of propensity for completing that life history within freshwater.
They're very possible. In fact, we did a study, oh gosh, it's probably been a decade or more ago, where we were trying to bring sleepers into the hatchery and raise them. And we collected broodstock from the rivers, a lot of the rivers around the hatchery, fairly lowland portions of the rivers. And we used those fish as broodstock, and we collected fish from Carite Reservoir. And what we found was we could spawn both. Fish from the river spawn just fine in captivity in fresh water. Fish from Carite Reservoir spawn just fine in captivity in fresh water. But we had almost 0% survival of the riverine fish from egg on up, whereas the Carite fish seemed to tolerate fresh water a lot better. And the only thing I could think of is those riverine fish were missing some salinity.
Yeah.
And, we now have this reservoir. The Carite Reservoir was impounded, I think, in 1918. So it's over 100 years old. So these fish, if these fish were originally impounded in there in 1918, we're talking, maybe 50 plus generations of time. Are we seeing evolution occur here?
Yeah. I mean, yeah. It'd be interesting to do genetic study to compare, because I'm almost certain they would be pretty distinct from the rest of the island.
Yeah. I definitely would like to do that somewhere down the line for sure. But no, the big mouth sleeper are a cool fish. We always wanted to find a way to try to bring them into the hatchery and spawn them, because we'd much rather have a native reservoir fishery in Puerto Rico than catching a bunch of exotic fish. Even though people have really come to love largemouth bass and peacock bass, having native species is always better than having non-native species because of the risks when they escape. But we haven't figured it out quite yet.
It's a challenge, definitely a challenge, but it would be cool.
Yeah. What haven't we covered, Gus?
So we talked about I guess we want to stick to some happy stuff, but we talked about non-native fish as a potential threat. But, there's other factors that are threatening native fishes in Puerto Rico. And one that's a big one that's in the spotlight now, especially in San Juan, is channelization. Something I studied from my master's research. Channelization usually affects whole stream ecosystems in a pretty negative way. So it's not too surprising, but of the streams that have been kind of concrete channelized in Puerto Rico, we find that there's very few of the native fishes tend to just not even have a lot of introduced fishes, just little things like guppies and stuff when you got these kind of concrete channels. And there's a big plan in place or kind of underway to further channelize the Rio Piedras. They're not going to, the good thing is that I know the plan does not include a fully concrete channel bottom anymore. That plan's been changed, I think, in good response to kind of research and new information, because that plan originally got put in place so many years ago. But that's one threat. Of course, we mentioned the dams, that you kind of lose the habitat for the native fishes. And so those are two really big ones. Of course, just like, climate change is definitely changing things. Droughts have seemed to be something that are especially maybe kind of disrupt that balance of the native and the introduced fishes, kind of like leaning toward the introduced fish in terms of the ability to compete or kind of reproduce. And so it seems like a extended drought, which are becoming more common with climate change, might favor those non-native fishes. So those are some of the things to kind of be aware of if you're interested in thinking about conservation in tropical islands.
With the channelization, so have you sampled within those channels?
Yeah, so that was kind of like the design of my master's research. So the Rio Piedras has, a lot of tributaries, and so the design of my master's research was to sample tributaries or sections of the Rio Piedras that had been channelized fully with concrete, that typical kind of trapezoidal concrete channel, ones that had been maybe just straightened or reinforced with things like riprap, and then things that appeared to be like natural channels, ones that hadn't had any like real engineering. And those kind of like intermediate ones that maybe get straightened, maybe reinforced with riprap or rock, that those fish assemblages don't look all that different from what we call the natural channel, but there's a drastic difference in ones that are channelized with concrete. They get really shallow, and there's almost no native fish. Sometimes if there's kind of broken parts of the channel, you'll find like tilapia just hanging out in a little hole in there, but it's mostly piscileids, things like guppies and green swordtail that live in those concrete channels typically.
Yeah, it seems like that there just wouldn't be any habitat within that. But I'm curious, is it simply there's no habitat there, or are those channelized concrete acting as barriers for upstream movement? So if you get above the channelization into the more natural stream, is that preventing migration from the ocean?
Yeah, that's a good question, and that will be, if this channelization continues, that will be a good question for it, because again, it's a different type of design, but I mean, there's going to be the construction phase will obviously be a big disturbance, and then the question will be like, can they move upstream of it? Because there's still a good portion of the Rio Piedras that won't be channelized under this plan, but it's going to be a question if that acts as a barrier. My sampling couldn't really answer that question because I didn't really have much examples of like a major section of like the sort of concrete channelized and then upstream. I think to some extent, yeah, I think it could be kind of a lot of these fish do have a pretty impressive ability to migrate. Again, we talked about how these Cycidium gobies can climb waterfalls, and so like if I think that it could be somewhat of a barrier for certain species, but I think some might be able to make it through a short section of channel. But I do remember one time I found one big mouth sleeper sitting in this one channel that had only guppies, and that thing must have just been eating guppies like crazy. But there was like it had made it up there a little bit into this channel, and there was like a sort of down tree just creating a little bit of backwater and depth, and it was just sitting right in that one spot. And so like it seems like if you give them the habitat, a lot of them would make it through. I mean, on a higher flow maybe, but of course I'm sure it's still gonna like not be as free of a migration for them. if you have these shallow channels.
Yeah, because they're engineered to move water efficiently, and when you move water that efficiently, then there's no safety zone. I guess something that can suction cup to the bottom and wiggle its way up could make it, but either they're almost dry, or they probably have such a high velocity of flow that some of the species would struggle, at least for long periods like that. If it was like a 100-yard section, they might be able to make it through, but if it's 5 miles long.
Yeah, I think that it would be a barrier. Yeah.
Well, speaking of barriers, you've worked a little bit, I know, on some of the dam removal projects in the tropics. How are those working out? Are you seeing return of fish to upstream areas where they couldn't make it before?
Yeah, so I worked on the Rio Grande Arecibo a lot for my PhD research, and there's another group that kind of evaluated how well that removal worked. But there was a small low head dam that was pretty far downstream on the Rio Grande Arecibo, and that's, to my knowledge, the only dam removal that's ever occurred in Puerto Rico was removing that small kind of low head dam. I think it was used just to back up a little water in the old days there's a sugarcane plantation next to it. And that dam, according to the research that was done on it, it seemed, even though that was a pretty low head dam and it was pretty porous, like it was actually made with karst, sort of porous rocks, and you could see that fish could move through that. That was a place where we've observed those gobies climbing. They would climb over that dam, and so fish could move through it, but it seemed like removing that barrier, even though it wasn't a complete barrier, still did kind of shift that fish assemblage to greater diversity or abundances. So it seemed to be successful, even though it was just kind of a small barrier. I would guess that any dam removal would be, with these amphibious species, would be highly effective, because again, there's almost this continuous pulses of migration that's occurring just to any system. And you see they have a very strong sort of rheotactic drive, like they swim against current. And so if you open it up for them, I think they come back, is my guess.
Another random question for you that you may or may not know the answer to. How long does a bigmouth sleeper live? That's
a really good question. We did try to do some work to age them. Oh man, I should look that up and see what was the. Is it all right, Wes, if I look that up? That's a good question.
Yeah, good. Now, where I'm going with that is we've caught adult sleepers in a number of the reservoirs, some of them for a number of years, and if they didn't get in through somebody dumping them in or climbing the dam, then they'd been in there for 30, 40 years.
Yeah, it could be possible. In some unpublished research, we estimated ages for bigmouth sleeper between 2 and 8 years old, but I would imagine that they could live much longer than that. That was from a total of just 51 bigmouth sleeper from the Mamaeus River. With otoliths and fin spines, so we went out and captured something around like 1,500 bigmouth sleeper and mountain mullet, and we marked them with OTC, so oxytetracycline. Some of your listeners, you might have talked about this before, but it leaves a fluorescent mark on hard structures. So in 1 year, we went out and injected fish with oxytetracycline in the Mamaeus River. Around 1,500 of them were ejected, and then we went out and recaptured them and tried to use that to validate age and growth. And so there were annual rings, but something that's known for tropical fish is that they seem to be like less consistent, and so they were very tough to age. But we did feel that we were seeing annual rings on both the otoliths and the fin spines, and again, we estimated ages between 2 and 8 in the 51 bigmouth sleeper that we recaptured.
Okay, the reason why I was asking is some of these reservoirs, Luchetti Reservoir and a couple of other systems, we would capture bigmouth sleepers. Wahataka was another one that for a while, every time we'd go out, we'd catch 1 or 2 bigmouth sleepers, but they're always big adults, the largest of the large fish. And then eventually, I would say probably 20 years ago, 15, 20 years ago, we caught our last one and would never catch them in any of those reservoirs again. And I wondered if they were remnants that were left over from original impoundment. So Lucchetti Reservoir, I believe, was in the early 1950s was impounded. So we were catching these fish probably in the late 1990s. So these fish would have been, 40 plus years old if that's how they got there. Or was there a particular flood event that had enough flow over the dam that they could move up, but not so much that it was just, I don't know. Or did an angler bring them in as bait and drop them in? Whatever it may be, we were catching fish in a number of reservoirs. They were always very large adults. Eventually, they all disappeared, and still Carite reservoir population just gets stronger and stronger every time we go there. So that's why I was asking about the age.
Yeah, that's a great question. I mean, yeah, I would not say that I think the oldest bigmouth sleeper out there is 8 years old. And that would be the same like if you sampled 51 smallmouth bass, they'd probably be, all 8 and under, but we know they can live longer than that. And so
yeah, but 40 would be a stretch, I would hope. I would think.
Yeah, you never know. I mean, and so I would guess that they can definitely live longer than that. And yeah, I mean, that's some interesting stuff. Like you could think about all kinds of scenarios. Like you said, like just a few that hung on from the dam, maybe some that were kind of like in Carite that were trying to have this population that was reproducing, but it was just kind of like disappearing over time, and you were kind of catching the last remnants of it. Who knows? Yeah, it's an interesting thing. You hear about that, and it's really intriguing that some of them were kind of hanging on in those reservoirs for a while.
Yeah. Well, one last thing, I think you and I can't get off of here without talking about our new book.
Oh, absolutely not. Yeah.
So, we have a brand new book out, Freshwater and Diadromous Fishes of Puerto Rico. Gus led the effort on this after the original leader passed away a few years ago. And it just came out, but this is AFS's first book, am I right? Their first book that is free to open access download. Not the hard copy, but the digital version of that is available for download for free. Go to their website, you click the digital access. It says it's, put it in cart and it like you're going to pay, but when you go to pay, it shows you zeros. So it is available out there, or you can buy the hard copy. And the hard copy is available. It's a real nice book. Gus and his crew did a great job taking some beautiful pictures on this thing. It's everything that we know about the rivers and the reservoirs of Puerto Rico. Even covers some of the estuarine fish. Talks about all this life history stuff and the threats to the island and everything we talked about today on the podcast with a whole lot more detail.
Yep. Definitely check it out if you're at all interested. And, if you're also interested in a lot of the fishes would apply to other Caribbean islands, right? So, and you're probably not going to find a similar book for like the Dominican Republic or Cuba or, the rest of the Caribbean region. So I think could be useful to you if you're visiting other places as well.
Yeah, and the threats are the same too. I know I went over to the DR, 15 years ago or so to try to help them with the Clarias catfish, which is causing problems there as well. So a lot of similar problems, similar habitats, similar fish species, a lot of the same fish species. Well, Gus, had fun today.
Yeah, this is awesome, Wes. Fun. I love, we always love talking about Puerto Rico fish together, so appreciate you having me on.
Well, we're glad to have you on, and thanks for coming. Everybody, thanks for listening to Fish University, and please catch us on our next episode. Fish University is hosted by Wes Neal, an employee of Mississippi State University Extension Service and a faculty member in the Department of Wildlife, Fisheries, and Aquaculture. This podcast is part of the Natural Resources University network of podcasts. Funding was provided by the Renewable Resources Extension Act. If you have questions or suggestions, please go to the Extension website at extension.mississippistate.edu. Click on Natural Resources and then select the Fisheries tab in the drop-down menu. or you can email me at wes.neal@msstate.edu.